we'd like to clarify the idea of hypothesis tests just a little bit more. So suppose that, going back to a simple example, you have 16 tosses of a coin. Suppose that your friend tosses this coin and counts 15 heads. So a total of 15 heads are observed, and your question is this coin unfair? Well, let's think about this. So your hypothesis is that it's potentially an unfair coin. You want to determine that. So you want to determine if the true proportion of heads is greater than 50%. That's your speculation. Remember, this just represents the population of all coin tosses with this particular coin. So you're speculating that it's going to toss on average more than 50% heads. Well, under the null hypothesis, which is, this might be a little bit easier to state first, we would assume that the coin is not unfair. So we're not proving the null hypothesis. We're just trying to see if there's this idea of evidence beyond a reasonable doubt. So is this right here evidence beyond a reasonable doubt that this coin is biased, that it has more than 50% chance of landing on heads? Well, at first you might say, absolutely, 15 out of 16, I mean, that's very unlikely. But another person might come along and say, you know what? Although it might be unlikely, it can still happen. So how do you know that this wasn't just a fluke sample observation? Okay, well, there are a couple of ways we could do this to test this idea. Here's a nice little applet that you can see the address here, so if you want to go and play around with this, I encourage you to. So if we set the probability of heads to the assumed 50%, and in this case we have the 16 total tosses, and we only go for one repetition, so we carry this experiment out one time of 16 tosses, and we press tell it to toss. So here are the outcomes. We got 7 heads out of the 16 tosses, which percentage-wise, we'd expect 8. So we got a little under. Well, does that indicate that this 50% chance is actually false? Well, this is the idea of sampling variability, because in the next sample, I get 6. In the next sample, I got 6 again. In the next sample, I got 8 heads. In the next sample, I got 11 heads. So this idea of each 16 toss sequence producing a different number of heads is this idea of sampling variability, which is why, coming back here, the person who says, well, you know what, it can happen, that's why that person actually does have some validity to their argument. So we need to determine probabilistically how unreasonable it is for a fair coin to get exactly 15 heads. That's why we typically say under the null hypothesis. So if this is a fair coin, how unlikely is it that we get 15 heads? Well, let me carry it around so I don't have to keep pressing the toss button. I'll say, carry this experiment out 10 times and record the results. So here are all the possibilities. Look, even one time there were 3 heads tossed in a 16 toss sequence. Let's do it 100 times and see what would happen. So it does it fairly quickly, and we notice that we do get a lot of variability, that in some cases there were as few as 2 heads, in some cases there were as many as 14, but we notice that the bulk of all outcomes was between 5 and 12. So it's very unlikely that we get less than 5, and it's very unlikely that we get more than 12. Just to be sure, let's do this 1,000 times. Well, there we go again. Still between about 5 and 11, and the 14, the 3, 2, 1, the 15, 16 seem to be very, very, very unlikely. So in this case, we would probably say, you know what, there is strong evidence here to indicate that 15 wouldn't happen just by chance, because it appears that it never does. So we have a fairly strong argument here. Now, you can continue tossing it, and somebody might say, well, I don't trust you. What if even after 10,000 tosses, 10,000 repetitions of 16 tosses, let's see if we can actually do this. That might take a little while. I think we're trying to do too much with this applet. So anyway, we're noticing that it's very unlikely to get 15. Well, this is again based on a finite number of samples, so we can't be sure that even 1,000 is enough to validate our point. So what do? Well, this is where we get to come over to the binomial distribution.